Welcome to our deep dive, taking us back to ancient Greece. We're going to explore the origins of Western scientific thought. We'll be using excerpts from Erwin Schrödinger's book, Nature and the Greeks, and his essay, Science and Humanism.
Those are great sources. So much to unpack there.
Exactly. We're going to talk about how those thinkers saw the world, what their big ideas were, and how those ideas connect to modern science.
It's amazing how these ancient ideas are still relevant today. It's like,
It is, and we'll uncover these aha moments that might completely change how you see things.
we're going to be like time-traveling detectives searching for the roots of how we understand the universe.
Love that. So let's begin our journey by diving into this. It's a big one, the conflict between reason and our senses.
Yeah, that's been a driving force in knowledge for centuries. How much can we trust our senses? How much should we rely on pure thought?
It's such a tricky question. We've got Parmenides arguing that true reality only exists in thought and the sensory world is just an illusion. And we have Protagoras saying, man is the measure of all things. What do you make of those?
Both raise super important questions about, well, about reality and how we experience it, right? Parmenides' statement, the thing that is, and cannot not be, is.
Well,
It's a head scratcher for sure. It suggests that that change is an illusion and that only one unchanging reality exists. And this idea was powerful. It influenced thinkers like Plato.
it makes you wonder, though, if that perspective came from, I don't know, always observing the same things or maybe dismissing the things that didn't fit into this idea of a singular, unchanging reality.
Yeah, yeah. And then you have Protagoras emphasizing the human perspective in acquiring knowledge. He's forcing us to think about how our perceptions and interpretations shape how we understand the world.
So how do we separate our own perceptions from the true nature of reality? I mean,
That's the million-dollar question, yeah. It's a question that still challenges scientists and philosophers today.
so Democritus tackles this. He believed in the atomic theory, the idea that everything is made up of these tiny particles. But he also acknowledged that even a theory like that is ultimately rooted in our sense perceptions.
He does so with a good sense of humor, too. He imagines a dialogue where the senses are challenging reason, saying, "Poor intellect, do you hope to defeat us while from us you borrow your evidence? Your victory is your defeat."
Almost as if he's saying they're not enemies, but partners in our quest for knowledge.
Absolutely. He was ahead of his time in recognizing that interplay between the two. It's a reminder that even our most complex scientific models are built on a foundation of those sensory experiences.
Let's move on from the mind-bending Parmenides and Protagoras to the Pythagoreans, a group with a fascinating perspective on the universe. They were obsessed with numbers, almost to a mystical level.
Things are numbers, was their core belief. That came from Pythagoras' discovery of the mathematical ratios in musical harmony.
Wow, music and math. Can you give an example of how this translated into their worldview?
Yeah, so they assigned deep significance to specific numbers. For them, justice was represented by a square number, completeness by a triangular number, and the number 10 held like a sacred cosmic meaning.
Their concept that things are numbers feels like it anticipates a fundamental concept in science.
Yeah, it foreshadows the idea that mathematics can help us unlock these hidden patterns and connections in the universe, like you see with the golden ratio. It appears everywhere in nature, from seashells and flowers to galaxies. It's incredible.
I'm always amazed by how they made these connections without advanced math.
Well, they were pioneers in using geometric constructions to solve problems that we now use algebra for. For instance, they figured out how to find the square root of 2, which is an irrational number, and they did it just using circles and lines.
That's so impressive. It really highlights their ingenuity and how much they could accomplish with limited tools.
It emphasizes that math is not just about, crunching numbers. It's about uncovering those underlying structures and patterns of reality.
Okay, my head is spinning from all this talk about numbers. Let's move on to a group that really embraced a scientific approach, the Ionians.
Now, these guys were revolutionaries. Thales, Anaximander, and Anaximenes, they were the first to really embrace the scientific outlook, seeking explanations based on observation and rational thought rather than divine intervention.
The one with the gods controlling everything.
Right. So Thales was a pioneer. Instead of attributing natural phenomena to the whims of the gods, he sought natural explanations for things like earthquakes and eclipses. He also proposed that all matter originates from a single fundamental substance. Now, he thought this was water. But the key here is that he was looking for this unifying principle behind the diversity of the physical world.
It's fascinating. It's almost like he had a sense that something fundamental is conserved throughout all those changes we see, like how water can become ice or steam, but still fundamentally water.
Yeah.
You know what I mean?
Exactly. That's very much in line with the modern concept of conservation of matter and energy. And then you have Anaximenes building on those ideas, suggesting that changes in matter result from rarefaction and condensation, kind of a precursor to the atomic theory.
So they were already starting to think about the world in terms of particles.
In a way, yes. They were grappling with, with the question of how matter changes form while remaining fundamentally the same. Their observations and insights paved the way for later thinkers like Democritus and his concept of atoms.
It's amazing how these early thinkers develop such groundbreaking ideas simply by observing the world around them.
It shows you the power of observation and that human drive to understand the universe. And, it's interesting, the Ionians were seafaring people, constantly interacting with nature. Their practical knowledge likely influenced their scientific thinking.
That's a great point. It highlights that connection between our lived experiences and how we try to understand the world.
Now, speaking of groundbreaking thinkers, let's delve into Democritus and his revolutionary idea, atomism.
All right. I'm ready. Hit me with it. Okay, so Democritus, his ideas. Lay it on me.
So Democritus, he envisioned a universe made up of these indivisible particles, atoms, moving in empty space.
Atoms. Sounds pretty modern, huh?
Aye. But back then, this was radical. The prevailing view was that the universe was filled with this continuous substance.
You mentioned Aristotle later called that substance ether, right? So Democritus is proposing that it's not this, smooth flow, but built from these tiny building blocks.
Exactly. A real paradigm shift. And you know what? This idea of a continuous substance, it actually held back scientific progress for centuries. Democritus's atomism, it offered a whole new way to think about matter, about change.
Yeah, I see that. It's a big deal. And this idea of atoms, it sort of addresses this thing that's always boggled me, that infinite divisibility of matter. Like, if you keep dividing something in half, can you do that forever? Makes my head spin.
Oh, it puzzled the ancient Greeks, too. And Democritus's atoms, they offered a solution. He said these atoms, they're the ultimate units of matter, You can't divide them any further. That's it, the limit.
Okay, that makes sense. But I'm curious, how did he even come up with this idea? Was there any, I don't know, evidence? Or was it more like just a brilliant guess?
Well, it's a good question. It shows how those scientific theories, they often come from a mix of observation, reasoning, imagination. Remember those Ionian philosophers, how they were trying to understand how matter changes form? Like water becoming ice, steam.
Right. They had that idea of rarefaction, condensation, things getting less or more dense.
Yeah, but think about it. A continuous substance just changing density. It raises some questions. Why doesn't everything blend together? Why are there those clear distinctions between different states of matter?
So Democritus's atoms, they help explain how those transitions happen, becoming more spaced out or packed together, but without the atoms themselves actually changing.
Exactly. The atoms, they stay the same. They're the unchanging blocks, and it's how they're arranged, their movement, that creates all the variety we see.
Like those construction toys, where you can build so many different things with the same pieces just by connecting them differently.
Perfect analogy. And that highlights something key about atomism. It bridges that gap between the continuous world, like in geometry, and the world of physical objects, those distinct things.
Okay, so ancient atomism, how does it compare to how we understand atoms today? Are they the same idea?
Well, there are definite similarities, but there are differences too. Both try to explain those properties of matter using fundamental particles that don't change.
But we know now that atoms aren't really indivisible.
Right.
There's protons, neutrons, electrons, and even those can be broken down further.
You got it. And what's maybe even more important, modern atomism, it's built on tons of experimental evidence. Like we can see individual atoms now even manipulate them. Ancient atomism, as insightful as it was mainly a thought experiment, a brilliant intuition, but it didn't have that empirical backing that we've developed.
Amazing how far we've come since then.
It is, right. And it raises an interesting question. Is this whole idea of atoms, is it reflecting how the world truly is? Or is it more about how our minds work? Like maybe we impose that kind of structure, that discreteness on a universe that might be continuous at its core.
Whoa, deep question. It's like asking, is math something we invented? Or did we discover it?
Exactly. And that brings us to something really fascinating and maybe a bit unsettling in modern physics. Quantum mechanics. It suggests that our ideas about space, time, that continuity might need some revising.
Quantum mechanics, I've heard about it. It's supposed to be super weird. I never really understood what it's all about.
So imagine a world where those particles, they can be in multiple states at once, or they can tunnel through barriers that seem impossible to pass. And their properties, they're not even defined until they're observed.
Sounds pretty weird, yeah. But how does this connect back to atoms and continuity?
Well, quantum mechanics challenges our assumptions about how things work at the most basic level. It suggests that reality, at its heart, it might be more like a series of jumps, quantum leaps, instead of that smooth flow.
We've come full circle back to the Greeks and their struggle with infinity.
It's true. Some questions just never get old. That's what makes this dive so cool. We're exploring ideas that have been around for millennia, and they're still relevant to how we understand the universe today.
It really hits you that science isn't just about those answers, but about asking the right questions, the ones that push us to the edge of what we can grasp.
And those questions, they often lead back to those big mysteries. The nature of reality, the role of the observer, the limits of what we can even know.
Okay, I need a minute to process all that
Oh.
before my brain melts. Let's switch gears a bit. Schrödinger also had some interesting ideas about how science fits into the bigger picture of human life. What did he say about that?
He argued against that view of science as just like practical applications. He believed that scientific knowledge, it has value in itself, just like any other kind of knowledge. It's not just about gadgets or cures, but about understanding ourselves and our place in the universe.
It's like that classic Greek saying, know thyself.
Exactly. Schrödinger saw science as a part of that search for self-knowledge, something that's both personal and universal.
He also had that really thought-provoking idea that mind and matter might be made of the same fundamental elements, but arranged differently. Whoa, that's going to take some time to unpack.
Right. It really challenges us to think differently, and it connects to another concern he had, what he called the barbarism of specialization. He worried that as scientists get more and more focused in their own little areas, they lose sight of the bigger context, the purpose of it all.
I get that, like getting lost in the details and forgetting the big picture, that human story that science is part of.
Exactly. He quoted the Spanish philosopher Ortega y Gasset, who said that those specialized scientists are like mass men, contributing to knowledge but not really understanding its true meaning.
That's a harsh critique, but I see their point. It's a reminder that science shouldn't be isolated from other parts of human experience.
And Schrödinger's message to scientists was pretty powerful. He said, if you cannot, in the long run, tell everyone what you have been doing, your doing has been worthless.
That's a statement. Every scientist, researcher, everyone who loves knowledge should think about that.
Right. It's a reminder that knowledge, it's most valuable when we share it, when we communicate it in a way that connects with others and, well, enriches our understanding of the world.
We've covered so much today. Reason versus the senses, those mystical numbers, the Ionians, Democritus' atomic theory, even Schrödinger's thoughts on matter, the observer, the whole purpose of scientific knowledge. My brain is full.
It's been an amazing journey through the history of ideas. And it's incredible to see how those ancient Greek thinkers laid the groundwork for so much of what we understand today.
Feels like we went on a whirlwind tour through the intellectual foundations of Western civilization. Where do we even go from here? It's like we traveled through time, exploring all these big ideas that have shaped how we see the world.
And it's the connections that make it so fascinating, how ancient thought links to modern science, those bridges between different areas of knowledge, even, how our own minds relate to the universe we're trying to understand.
About those connections, I'm still thinking about that idea Schrödinger had, that mind and matter might be made of the same stuff, just arranged differently.
It is a captivating thought. Makes you wonder if, those weird things we see in quantum mechanics with particles, if that could somehow be connected to how our consciousness works.
Wait, are you saying, our minds could actually be influencing those tiny particles? That sounds like, I don't know, almost science fiction.
It's a possibility that's been floating around for a while. Remember how we talked about the observer's role in quantum mechanics? Maybe that role is even deeper than we realize.
So instead of just observing the universe, are we, participating in creating it? That's wild.
It's a pretty radical idea, but it kind of flows naturally from what we've been discussing. If mind and matter are really interconnected, like Schrödinger said, then just the act of observing could be shaping what we observe.
Makes you question, what are the limits of what we can know? Are there mysteries we just can't solve with our current way of thinking?
It's humbling, for sure, but also exciting, right? The universe is full of mysteries. The more we learn, the more we realize how much we don't know.
Makes you want to keep exploring, keep asking those big questions, keep pushing those boundaries.
And that's what those ancient Greeks were all about. They questioned everything, embraced new ways of seeing the world. Their legacy isn't just their discoveries, but that spirit of inquiry that still drives us.
As we wrap up this deep dive into, well, the beginnings of scientific thought, I feel like I'm seeing the world with new eyes, looking for those connections, embracing those mysteries.
That's great. Keep looking for those connections, ask the bold questions, and never stop exploring. Who knows? Maybe the next big breakthrough will come from someone who dares to ask what seems impossible and shakes up everything we thought we knew.
This journey through the minds of those Greek thinkers has shown us how much those early ideas still shape our understanding of the universe.
And for anyone who's curious to learn more, I definitely recommend checking out Erwin Schrödinger's Nature and the Greeks and Science and Humanism. They're full of insights that'll make you think, make you question, really inspiring stuff.
Until next time, keep diving deep, keep those brains buzzing, and never lose that sense of wonder.